All right, here's our next index law. We're looking at what we call the power of a power. So what that really means is, in this situation, I've got a to the power m, but then I'm raising that again to the power n. So the question is, what is that going to look like? Right? Again, I want to think about relying on our previous index laws to try and develop this. So again, I'll just keep using base 2, hopefully that's easy enough. Let's take 2 squared all cubed. Right? What does that look like? Well, remember, what does it mean to cube something? It means I'm multiplying it by itself 3 times. What's inside the brackets here? Well, I've got 2 squared, right? So I know that's going to be 2 squared times 2 squared times 2 squared. And knowing from this index law here, if they're the same base, I can add the powers. So that's going to give me 2 to the power 6, right? And so I guess the question is, what's the relationship between these two numbers and this final result here? You might have already picked it. I'll do one more just to show you. Right? The whole idea is that if I've got something and I'm raising a power to a power, what's end up happening is, in this situation again, I'm getting 2 to the power 8, and so hopefully you can see now, okay, how do I get from 4 and 2 to 8, 2 and 3 to 6? I'm just multiplying these powers here, right? So 2 times 3 is 6, 4 times 2 is 8, and so my index law is going to be, if I have a to the power m raised to the power n, I'm just multiplying them out, okay? That's what I'm doing with this particular index law. What that means now is I can answer these questions quite nicely, right? Because I don't have to write out the expanded form each time. I can actually just use this shortcut method. So I can say in this case, well, a cubed to the power 5, that's just going to be a to the power 3 times 5, which is a to the power 15. Right? And so, like I've kind of been saying before, this step here isn't necessarily required, but I think it's good to show that you have a good understanding of what's going on. Yeah? Same thing here. Just be careful with these coefficients. Because that's actually outside the bracket, we kind of leave it by itself. It's not being affected by this. But in this case, these two powers are being multiplied, right? So I've got 2 times 3, I've got 2x to the power 6. Okay? All right, let's try another one. This one over here. So, same thing again. What I'm going to do is I want to think about, okay, I'm multiplying these two powers, and then I'm multiplying these two powers. So that's 6 times 3. And so that's going to give me b to the 20 multiplied by b to the 18. And so that's b squared. Okay? I'll write that a bit better. There we go. All right, next one. Same idea. So now this time we like to combine indices, right? So what I'm going to do is I'm going to say that this is going to be 4 m to the 4 raised to the power 6. So it's m to the 4 multiplied by 6, all of m cubed. And don't forget about your index laws. That becomes 24. And when I have division, that's when I actually subtract the indices, yeah? So it's going to be m to the power 21. So I wouldn't want to write this whole thing out 24 times. Instead, I can use the index law for that one, okay? So I'm actually going to change this example. Let's make that 12, and then let's raise this to the power 3. No. 3, and this one raised to the power 2. Okay, so I'll just change the example slightly, just so that we incorporate a few skills, right? So what skills are we incorporating here? Well, we're incorporating the fact that we multiply the indices here, but we leave the numbers, okay? So I want to do them separately first on the numerator. So 2c to the power 6 multiplied by 4c to the power 6, all divided by 16c to the power 12. Now, what happens when you have two indices with the same base? Well, what I can do is I can add these powers together, but remember, it's still a multiplication symbol, yeah? So I'm actually going to be multiplying the coefficients first, as I start off by doing. So I've got 2 times 4, which is 8, c to the power 12 over 16 c to the power 12. And this is what I meant by incorporating lots of different index laws, because c to the power 12 divided by c to the power 12, well, if you use your index laws, you'd recognize that that just becomes c to the power 0, which is just 1, or you can just think about, hang on, these are literally the same thing, right? They just divide through, okay? So this whole thing would divide through, which leaves me with 8 on 16. And what's 8 on 16? That's just half, okay? So to clarify what's happening here, you can think about it in two ways. If you have c to the power 12 divided by c to the power 12, one thing divided by the same thing, that's just going to be 1, right? Or you can think about using the index law by recognizing that you'd have to subtract these two indices, but then you just get 0, which is still 1. Okay, so there's a few ways of thinking about that. Either way, the result is still half. Okay, that's power of a power and a bit of a trickier one combining some index laws, but hopefully that gets you started.